Hello calculus student, this video is for chapter 4.8 L'Hopital's rule. L'Hopital's rule. L'Hopital's rule is a rule that you can use to find limits. So in chapter 2 and also in chapter 4.6 we learn some way to find limits. Basically in chapter 2 we say, you do direct substitution. If not, then you do what is it called, like factor and cancel and rationalizing and complex fraction simplification. And in chapter 4.6 we say you just keep on dividing 1 over x if you're doing a limit, okay, only if you're doing limits or limits to infinity. And then what about if none of those work? Like for example, you have a ratio of x or tangent x, you can't really factor them, but they're in indeterminate form, right? And then it is not to infinity, so you can divide x. So this rule lets you actually use derivative to find the limit. So what happened is, let's look at the rule. If f and g are differentiable, so they are differentiable over the interval containing a but not necessarily at a, and then if the limit of f of x at a equal to 0, that means when you do a direct substitution plug-in, it is 0. And when you do a direct substitution of plug-in of g of x is also equal to 0. Then if you are to find f of x over g of x, this ratio, the limit is as if you need to find limit x approaches a, f prime of x over g prime of x. That means you just do a derivative. The two limits are the same. And very often after you find a derivative of a function, it becomes simpler, or you can do some simplification to do direct substitution. So, and then this not only apply for x approaches 0 or 1, 2, 3, it can also apply to when your x approaches infinity or one-sided limit. So let's look at the book for the proof. Why does it work? So here it is under 4.8, L'Hopital rules. So what happens is they say, okay, limit x approaches a f of x. Because when you do direct substitution, you have top and bottom being equal to a. So you have f of a equal to 0 equal to g of a. And if they are 0, then why don't I just put them in the top? Minus f of a minus g of a in the bottom. And then you divide it by x minus a. Why can I divide it? Because x would not equal to a when you are doing a limit, so you can just safely divide it. And did you notice that the top looked like a limit definition of at a? So the top actually just become limit. If you just do the limit of the top, limit of the bottom, become two limits. And then it's just become f prime of a and g prime of a. And and then this is the definition of derivative. And due to continuity of f prime and g prime, and this would, if they're continuous, the f prime of a is actually equal to limit x approaches a f prime of a. I don't know if you still remember the continuity definition. And then due to the fact that if you do limit like this, you can just do limit. So you start off with a limit x approaches a f of x g of x. You end up doing limit x approaches a f prime of x g prime of x. They actually would reach the same limit. Okay, so this is the proof again, but to use it, you have to make sure that you have a 0 over 0 case, indeterminate form. It has to be like g of x over f of x over g of x. It has to be a ratio of two functions. You cannot just say one function. You cannot use it to do limit x approaches a f of x. Of course, that's not going to work. So let's try this. So please remember to do some direct substitution first to verify that it's indeterminate form first before you do the f prime. Another thing to remind you is we are doing f prime top and bottom, but it's not the quotient rule. It's the L'Hopital rule. L'Hopital rule said that the limit are the same if you do the derivative of individually top and bottom. Has nothing to do with quotient rule. A lot of people get confused. Okay, so first one, limit x approaches 0, x over tangent x. So do direct substitution. That's always what you should do. Is equal to 0 over 0. So indeterminate form, right? IDF, I think, Indeterminate Form. And so you can do L'Hopital rule. So it would say the limit would become x approaches 0. Derivative of x is 1. Derivative of tangent x is secant square x. Now you do direct substitution. Is 1 over 1. That's equal to 1. So the limit of the original function, although it's 0 over 0, is 1. And you do not do algebra factoring, cancelling. You do L'Hopital rule. Once you know how to do derivative. What about this? Let's do the direct substitution. That would be sine pi over ln1. We know ln1 is 0. Sine pi is 0. It is over 0 over 0. Indeterminate form. So we can do L'Hopital rule. Keep the same limit, but the inside can be changed as to the derivative. Derivative of cosine pi x. Derivative of sine pi x is cosine pi x times d dx of pi, which is pi. And then derivative of ln x is 1 over x. So do direct substitution. The bottom is 1. The top is cosine pi, and then cosine pi. Cosine pi is negative 1, right? In the unit circle, cosine of pi is negative 1. So it's negative pi over 1, negative pi. So the third is e of x minus 1 over x squared. It's a very popular question. Do direct substitution. You plug in e of 0 is 1, right? E of 0 minus 1, no, e of 0 is 1. 1 minus 1 is 0. And then the bottom is 0. So it's 0 over 0 indeterminate form. So we can do L'Hopital rule. Do not do L'Hopital rule right away. So do derivative of the top. So we still need to do limit. U of x is still u of x. 1 is nothing. And this was 2x, right? Now when we plug in 0, the top is 1. The bottom is 0. So this becomes infinity. The last one, we don't have space. I'll talk about this in class. And I think there is a question like that in your worksheet. Example 2. Even if it's not 0 over 0 case, we can still do it with infinity over infinity case. Why? Because 0 is 1 over infinity. So you can switch them around. If you have infinity over infinity, you can make it as, 1 over the infinity over 1 over the infinity. It becomes 0 over 0. So 0 over 0 is okay. You can still do L'Hopital rule. But you should confirm by doing substitution. 3 times infinity is infinity. 5 times infinity is still infinity. So you do L'Hopital rule. Do you notice that this is the one where you can do like the divided by x case, because we're doing infinity, right? So, but we don't need to. We can just do L'Hopital rule. Derivative of 3x is 3. Derivative of 5x is 5. So 3 over 5. It's a little faster than the divide by x method, although that works also. And then this one, so ln direct substitution will be ln 0 plus. So you still remember how the ln graph works. So if you do 0 plus psi is negative infinity. And so this is cotan 0. So this is the ln graph. You need to know how to graph those. The cotan is like that, right? As 0 positive, it go to infinity. So this is a negative infinity over infinity case. So it's still okay. So we can do a L'Hopital rule. Let's see what derivative of ln is 1 over x. Cotan is negative cosecant square x. Can I plug in now? So that would be cosecant is sine, right? Negative sine square x over x. And we are putting in 0. So the top is 0. The bottom is 0. So we have to do indeterminate form. Indeterminate form, we're going to do one more time. So the top would be 2 sine x, I should say it will be limit x approaches 0 plus the bar, and then cosine x, the bottom is 1. Now we do direct substitution. Sine 2, sine 0, cosine 0, that is equal to 0, and that's the final answer. You can see that we use L'Hopital rule 2 times. You can do repeated use of it. Okay, first time, second time. After you simplify it, you still have to check that it is in the indeterminate form before you can apply it. C, limits ln x over 5x. So plug in ln infinity is infinity, 5x is infinity, so it's the infinity over infinity case. So we can do L'Hopital rule. Same limit, x approaches infinity. What's the derivative of ln x? 1 over x. What is the derivative of 5x? Is 5. So it is 1 over 5x. But when x approaches infinity, 1 over anything, that is 0. Okay. So I'm going to stop here and we'll talk about other indeterminate form, namely 0 time infinity. Maybe you can cancel something. This because this will be 0.00001, but this is 1 million or something. You can cancel them. And also infinity minus infinity. Now notice if you have infinity times infinity or infinity plus infinity, that is infinity. But only when you have these two cases, you can rewrite them to 0 over 0 and then apply L'Hopital rule.